Hello guys, this is Samadan Kale and welcome to all of you on my YouTube channel. So guys, in this video we are going to see the practical number 10 of the third year BSc Mathematics of subject Python programming. So guys, before starting the today's video, please if you do not subscribe to my channel, please subscribe it and press the bell icon so that you will get the latest update of videos. And please guys like my video. Okay, so let us start the today's video. So this is a practical number 10, which is application of roots of equations and which is based on the unit 5 of the 5.1. Now guys, till this video, we have seen the SIMPy library. Okay. And in that SIMPy library, there are so many methods we have used for the linear algebra. So guys, for this finding the roots of equations, I could not found any method or any library to these equations. So I have defined the functions, and by using that functions, we can find the roots of the equation. So firstly, let us take the question. First question, explain the Newton-Raphson method to find the equation. So we have to explain the Newton's-Raphson method to find the root of the equation. Now guys, this is the Newton-Raphson method that you have learned. I hope in SY.B.Sc, if you are in SPPU, okay, if you are in a SPPU, then it is must you have learned the uh, this Newton-Raphson method in the SY.B.Sc. Okay, so I hope all of you learned this Newton-Raphson method in mathematics. So I will only tell this method in Python. I will only give the code. Okay. So let us start this code or this method. What is this method? So given function f of x on a floating number x, that means we have given any function which is on the floating number x, and we have to guess the initial root for that function. We have to guess the initial root and then find the root of the function in interval. We have to find the particular root of the function in the interval. So here f of x represent the algebraic or transcendental equation. It may be algebraic equation, it may be a transcendental equation. Okay. So guess value should be anything. Yes. So starting from initial guess, that means we have taken it as x1, and the Newton-Raphson method uses the formula. This formula, guys, xn plus 1. That means the next value of x is xn plus 1 is equal to xn minus f of xn upon f dash of xn. Okay. So firstly, guys, what we have to taken, this is the algorithm for this method. What is the algorithm? In the input, we have to give the initial x. We have to give the initial x, then function x, that means f of x, and the function's derivative f of f dash of x. And in the output, it will give us the root of the function. Okay. So how it will be? So first step is, guys, compute values of function. Okay, we have to first compute the values of function and derivative of function for the given initial value, and then we have to compute the h. So this h is given by f of x upon f dash of x. Okay, all of we know. While this h is greater than allowed error, suppose in the question we have given some error 0.0001. So if this h is greater than that error, then this h will be function, that is f of x upon derivative of f of x, and this x value should be x minus h, and that is our root. Okay guys, so this is the first question. Next, we move to the second question. So what is second question? Explain the false position method to find the root of equation. Same, we can explain this false position method, and it is also known as regular falsi method. So for the given function, again, it is on a floating point number. We have two numbers a and b such that this condition should satisfy. F of a into f of b is equal to 0, and f of x should be continuous in the closed interval ab. Here f of x represent the algebraic and transcendental equation, and we have to find the root of the function in the particular interval, that is closed interval a to b. Okay. So this method will assume that the function is continuous in that interval that you have given, that is closed interval ab, and the given two numbers a and b are such that this condition should be satisfied. This f of a is into f of b is less than 0. Okay, and if this f of c equal to 0, then c is the root of the solution. So instead of this a and b, some c is some c, and if you substitute f of c, if it is equal to 0, then c is the root of that solution. Okay. So else f of c is not equal to 0. If it is not equal to 0, then we have to check this. If the value of f of a into f of c is less than 0, then root lies between a and c. So we recur for a and c. Else, again in this else, we have written if f of b into f of c is less than 0, then root lies between b and c. Yes. And else the given function doesn't follow the assumption. That means the above assumption does not follow. Okay. So you can write it. Now, next question. That is the fourth question. Why I'm not taking the third question, guys? Because third question and second question are same. Okay. So what is the fourth question, guys? A root of f of x is equal to x cube minus 10x square plus 5 equal to 0 lies close to the 0.7. So compute this root with the Newton-Raphson method. Okay. We have to compute this root of the equation by using the Newton-Raphson method. So guys, I have defined the function. What is the function? Newton-Raphson. So in this, I have to give the initial value. Okay, I have to give the initial value that I substituted x. Now in this function, again, I am defining the function. Define f of x, written. Now what is our function, guys? This x cube minus 10x square. So that I am editing 10 into x square and plus 5. Okay, plus 5. So this is our function. Now I'm defining another function df of x. That means it's a derivative of function f of x. So what is derivative? 3x square as it is. Now what's the derivative? 10 into 2, that is 20. Okay, that is 20 and x. Okay, 20x. Okay, 3x square minus 20x is the derivative. Then we have to find the h value. So at the starting, in the first question, we have seen h is equal to f of x upon derivative of f of x. So this is h is equal to f of x upon derivative of f of x. While, now I am using the while loop, while the absolute value of h is greater than this error, guys. So now in this question, we don't have given the error. So I'm taking this error 0.001. Yes. So if the absolute value of h is greater than this error, then h is equal to f of x upon derivative of f of x, and the value of x is equal to x minus h. Okay. Then we have to print this x only. We have to print the x only. I'm using here percent 0.2 f percent x. Okay. This is format, guys. And if I run this function now, okay, if I run, it's run. Now I have to use x is equal to 0.7. X is equal to 0.7, and if I run this, so I will get 0.73. Yes, so they have told it is lies close to the x is equal to 0.7. This is the root. So which is the root, guys? 0.73 is the root of the given equation, which is lies nearly and closely to the 0.7. Okay. So I hope, guys, all of you understood this question. Now let us take the sixth question. So why sixth question, guys? Again, question number 5 and question number 4. Both are same. So no need to write these questions. Okay. So instead of the question 5, you can take any question. That means you can take any polynomial equation, any quadratic or transcendental equation, and you can solve it. Okay. Now next question, sixth question. Obtain these roots correct to 3 decimal places of the equation x cube minus 3x plus 1 is equal to 0 using the method of false position in the interval 0 to 1 with the tolerable error 0.00001. So this is our question, guys. Okay. Now I am defining the function, that is the regular falsi, and in this regular falsi function I'm going to take these 3 values, that is x0, x1 and e. X0, x1 and e. These are the 3 values. So firstly, I'm using the while loop. That's why step 1, step equal to first step is 1 and condition is equal to true. Then while this condition, that means it is a true already. Okay. Then it will go to the while loop. So what is x2 value? X2 is equal to x0 minus x1 minus x0 into f of x0 upon f of x1 minus f of x0. So this is the condition, guys, in the regular falsi method. This is the value of x2 and we have to print this value of x2 with step x2 and its f of x2 value. Okay. So firstly, what is the step 1, 2 or 3, anything, and then x2's value, x2 root this x2 value, and then f of x2 at x2, what is the value of function f, that we have to take. Now if this f of x0 into f of x2 is less than 0, yes, it will check now condition. If it is less than 0, then x1 is equal to x2, else x0 is equal to x2. Okay. Then we have to increase the steps. So step is equal to step plus 1. So it will continuously. Okay. And condition is equal to, what is condition? Absolute value of f of x2 is greater than e. If the absolute value of f of x2 greater than e, then the while loop get stopped. Okay. Now, and lastly, we have print this format x2 value. So I'm defining the function now. For this one, I want the function. So what is our function, guys? Our function is x cube minus 3x plus 1. So I am running this function. It's run. Now I'm defining this function. Let us see, x cube minus 3x plus 1, and I run this cell also. Okay. Now I have to use the regular falsi method. So in this regular falsi, I'm going to take the x0. X0 means first element, this interval's first element, and x1 means the second element. E means this value, guys. So I'm using x0 is equal to 0, x1 is equal to 1, and e is equal to 0.00001. And let us see, this is my function regular falsi 0 1 0.00001. And if I run this, so I'm getting these many iterations. I'm getting these many iterations. So iteration 1, for the iteration 1, x2's value is 0.5. Iteration 2, x2's value is 3.6. For third iteration, 3.4, 3.47, 3.473, 3.472. Okay. And it's the less, that is it's taken. So 0.34797. Okay. So it's approximate value to the given equation and it's the root. Now let us take the next question. Seventh question. We have to develop the Python program for the bisection method to find the root of the equation. I hope, guys, all of you understood the all of you have learned the bisection method. If you do not learn the bisection method, you can learn on Google itself. You can just type on Google bisection method in mathematics. You will get bisection method. Okay. So I'm defining this bisection. Here again, we have to give two parameters, A and B. So if this f of A into f of B is greater than equal to 0, the condition is there. If this condition is satisfied, it will print, please enter right values of A and B. That means we need this is less than 0. F of A into f of B should less than 0. Okay. So C is equal to A. Now I'm taking the C is equal to A while this is the condition. What is condition? B minus A is greater than equal to 0.01. If it is satisfied, then the value of C will be A plus B upon 2. A plus B upon 2. And now I'm using the conditions on C, f of C. So if f of C equal to 0.0, we have to break the value. Yes. And if it is not, if f of C into f of A is less than 0, yes, then B equal to C, and else A equal to C. And lastly, we are printing this format as C value. If I run this, so it's run now. Now, for example, I'm taking this function. I'm taking this function f of x. and return this function. Okay, so I run this function x cube minus x square plus 2, and I'm taking bisection of minus 200 and 300. So it will take this one. If I'm using bisection of this, bisection of minus 1 comma 9, then what it will give? Let's run it. So it will give me the value. Please enter the right values of a and b. Yes, a and b. Now I have to use some value. Suppose I'm taking is minus 2. Then what will happen? Let us see. It again give me, please enter the right values of a and b. It will calculate the root, but in that, not in that case. Okay. So suppose I'm using here this minus 5 and it is 8. Then what will happen? Let's see. It will give me the output, that is a minus 0.9946 by using the bisection method. So guys, this is the practical number 10 I have explained to you. Okay, so I hope all of you understood this practical. It's a lengthy one programs, but you have to understood it by yourself. Okay, so it's very easy if you are familiar with these methods in mathematics. Okay, as I am familiar with these methods in mathematics, I'm able to give the and I'm able to define these functions for the methods. Okay, so thank you for watching the video. We will meet in the next practical.